Okay, so this video is just going to be largely a summary or review of what you have looked at in the Desmos activity. So it is highly recommended, required really, in this class to look at doing the Desmos activity first before you work through this note sheet, or do them at the same time. You can work through this sheet at the same time. But everything, if you don't do the Desmos activity before doing this sheet, you may not understand completely everything that was happening in the activity. So this lesson is just about quickly reviewing the A value. So we've seen the A value previously in previous units. Factored form and standard form all have the same A value, just as it's the same A value for the vertex form. And I've referred to this as the stretch factor in the past. And the reason why that is because A controls the shape of your parabola. It can be stretched. So if you had a base parabola look like this, you can stretch it vertically to make the parabola look something like this, or you can compress it vertically to make it a little bit wider, like this. Okay, so we know it's so the stretch is the size of the shape of this parabola is controlled by the value of A. And we find that if the value of A is larger than 1, we have a situation where we have a vertical stretch. The best way to visualize this is think of the parabola as half of a rubber band. And if you stretch the rubber band vertically, well, you'd get a stretched rubber band, and the walls of your rubber band would become narrower. And so that's the way I like to visualize a vertical stretch. So it's a stretch, it's vertical. Think of the rubber band, you're stretching it up and down, and the walls of the rubber band are getting narrower. Now, if the A value is between 0 and 1, we call that a vertical compression. Okay, and think of the rubber band again. If you compressed it vertically, it gets wider. Right, and here's your top half of the rubber band, right? So it gets wider, but what you're doing is vertically you're compressing it. You're compressing it this way, but it gets wider this way, right? Okay, and if the A value is negative, the transformation is called a reflection in the x-axis, and this is when your parabola opens down because your A value is negative. So which of these parabolas have been vertically stretched? Well, if you look at parabolas that have an A value greater than 1, so here we have an A value of 2, so that's a stretched parabola. Okay, this one here also has been stretched because the A value is 6. The negative sign also just means it's been reflected. So reflected and stretched. Okay, 5 over 4 is a value bigger than 1, so this parabola has been stretched as well. 1.4 is a value bigger than 1, so this is also stretched. So whether you have fractions or decimals, it still counts too. 3 over 4 is 0.75, that's smaller. 1 over 2 is 0.5, so that's not quite bigger than 1, so those are not stretched. So the ones that are compressed are the ones that have an A value between 0 and 1. So A is between, let's write some, so 0, A is between 0 and 1. And so 1 over 2 is a value between 0 and 1. 0.6 is a value between 0 and 1, ignoring the negative. So the negative just means it's reflected. So reflected and compressed. 5 over 4 is not. 0.08 is, even though it's close to 0, it still is between 0 and 1. And 3 over 4 is also. So we're going to say that that's also reflected and compressed. All right. So compared to the graph of y equals x squared, the graph of y equals ax squared is vertically stretched or compressed by the A value, meaning that each y value from y equals x squared is multiplied by A, right? Okay, so the base graph is y equals x squared. Just imagine taking all your y values, multiplying them by A. That's ax squared, right? So y times A is equal to ax squared from your base graph, right? So that's what it is. So base graph becomes ax squared by multiplying the y values by A. So if I took the base graph of y equals x squared, let's just write those points down again. So the arbitrary x values and the corresponding y values 9, 4, 1, 0, 1, 4, 9. And let's just quickly graphing a couple of transformations. So here we have let's make a quick correction here. This should not be. Let's just make a quick correction. So this will say y equals uh, negative 4x squared, and this one over here will be y equals 3x squared. Meant to illustrate some a values here. So the a value in this case is negative 4. So all you're going to be doing is multiplying the y values by negative 4 from your base graph. And for this one, you're going to be multiplying them by 3. So you can keep the x values the way they are, because a does not affect the x values. Only h does. And now we're going to take the y values. So these y values here. And I'm going to multiply them by negative 4 to this column over here. So here I'd have negative 36, negative 16, negative 4, 0, negative 4, negative 16, and negative 36. And then over here I would have to multiply these base function y values by 3. So here I have 27, 12, 3, 0, 3, 12, and 27. And then I can plot them on the grid to show you the changes as well. So I'll plot the transform graph. So 0, 0, 1 and negative 4, negative 1, negative 4, and then just connect those points to create my parabola. So it's a stretch parabola and it's reflected. And the second graph would look something like this. So again, another stretch graph. Vertex for all of these are still 0, 0. And the axis of symmetry is equal to 0. So the a value does not affect the axis of symmetry, nor does it affect the vertex unless there is another h and k transformation. Okay, so how can I determine the equation for a parabola? So going backwards, sometimes we're given the equation, asked to graph it. What if we're given the graph and asked to find the equation? Well, the nice thing about graphs like this is you get the vertex. Okay, so you're used to looking at the x-intercepts and starting with the factored form. But if you're not given those two values, you can start with the vertex using the vertex form. So the vertex form is y equals a times x minus h squared plus k. So if my vertex is 1 and 5, that means h is equal to 1, k is equal to 5. Because the vertex is just h comma k. So if I put those values into my equation, I get y equals a times x minus, because the formula has to have the minus, h, which is 1 squared, and k is 5, so I'll say plus 5. And the only thing missing in this equation is a. Well, I could solve for a if I substitute a known point. Now, I can't use the vertex since I already used it here for h and k. So I'll use another point. So I'll use this one here given here that's 3 and 2. So I'll substitute 3 and 2 and solve for a. So my y value will be 2 equals a times x will be 3 minus 1 squared plus 5. Okay? Then you solve for a. Just use your order of operations and you'll be fine. So if I subtract, let's do the brackets. So 2 equals a times 3 minus 1 is 2, and then that squared is 4. So a times 4 plus 5. So I'll subtract 5 from both sides. So 2 minus 5 equals a times 4. I can just write as 4a, and the 5 over there is gone now. because I subtracted 5 on the right side as well. 2 minus 5 is negative 3, and that's equal to 4a, and if I divide both sides by 4, I get a equals negative 3 over 4. And so the equation, therefore, is y equals negative 3 over 4 times x minus 1 squared plus 5. And that's your equation of this parabola. And that's how you do it if you're looking for an equation of a parabola in vertex form. Okay, and that ends this video.